How do you integration test stateful interactions across services? Imagine trying to piece together a puzzle where each piece depends on the others fitting perfectly. That's what testing stateful interactions across services feels like. When you have multiple backend components like application, programming interfaces, databases, and server-side logic working together, ensuring they all behave correctly is essential, especially when each service might have its own database or manage its own state. First, you need to understand what makes these interactions stateful. It's not just about sending a request and getting a response. It's about how the system remembers previous actions. For example, when a user logs in and then places an order, the system needs to keep track of that login session and order details across different services. This ongoing memory is what makes it stateful. Next, set up test environments that mirror real systems as closely as possible. Instead of just using mock services, create isolated test environments or sandboxes. These environments run actual service instances and databases, so the state is preserved just like in production. This way, tests reflected real-world behavior, and you can catch issues related to state sharing or data consistency. Managing test data is another key part. Each service might have its own database, so you need to seed these databases with initial data that makes sense for your tests. After each test run, clean up the data to avoid interference with other tests. This ensures your tests are independent and reliable. Keeping data consistent across services prevents false failures and makes debugging easier. Contract testing is also vital. It checks that services agree on data formats and behaviors. When services evolve, contract tests make sure they still understand each other, reducing errors caused by mismatched expectations. These tests act as a safety net for compatibility, especially when dealing with complex state exchanges. Focus your tests on key interaction points. This includes APIs, message queues, and database transactions. For example, verify that when a service updates its data, the change propagates correctly to other services. Test multi-step workflows to see if the overall process completes successfully with the correct state at each step. When multiple services from a subsystem, consider component testing. Treat these groups as a single unit to check their combined behavior. This helps identify issues like data mismatches or unintended side effects that might not show up when testing services separately. Automate your integration tests early in the development cycle. Run them frequently, such as on every pull request, to catch state-related issues as soon as they appear. This prevents problems from piling up and reaching later stages like staging or production. Be cautious of flaky tests. State can cause tests to fail unpredictably if data isn't reset properly or if services have side effects. Design your tests to reset state between runs and avoid dependencies on external systems or timing. This keeps your tests stable and trustworthy. In practical terms, this means setting up test databases for each service with known initial states. Use container orchestration tools or service meshes to deploy isolated test instances that mimic real interactions. Write tests that simulate real user workflows crossing multiple services, checking state changes at each step. Combine contract tests to ensure message formats and API contracts stay consistent. Always clean up test data after each run to keep tests independent. By following these steps, testing stateful interactions across services becomes manageable. It helps you confirm that your backend workflows work smoothly in a distributed environment, giving you confidence in your system's reliability.